We're now going to go through this. So it says y is equal to a to the x, where a is greater than 1. So we're going to consider the function this and consider the function this. We're going to fill out some table of values, and then we're going to sketch them just to get a sense of how these graphs operate. Okay, so in filling out a table of values, remember what you do is we've got x is equal to this. We're going to sub that into the x spot and see what we get out as our y value. So let's begin. For this one right here, what I'm going to do is I'm going to sub -2 into the x spot. So it's going to be 2 raised to the -2. Now remember, when you've got a negative exponent, you take the reciprocal of it, and now it turns into a positive. What is 2 squared? It's 1 on 4. So that means when I let x be equal to -2, I get 1 on 4 out. And then we move on to the next one. So this is what's happening when I let x be equal to -1. So this will be y is equal to 2 raised to the -1. Again, you take the reciprocal of that, so you're going to end up with this. So that means y is equal to a half when x is equal to -1. For some of these, you won't have to put working out in. So for instance, when you raise any number to 0, you know that you get 1 out. No working required here. So too for this one, we don't have to put working out here. If I take x and make it 1, we know 2 raised to the 1 is just 2. So too here, if I was to put 2 into the x spot, what are you going to get out? You're going to get 4 out. So no big surprises as to what's happening there. Let's now plot all these points onto our graph. So let's zoom out here a bit, and let's see if we can plot them. So as you can see, when I have x is equal to -2, I get a quarter out. Now, if this is 1, a quarter will be like here. Then when I put in -1, I get a half out. So that will be a bit further up. When I put 0 in, I get 1 out. That will be here. When I put 1 in, I get 2 out. 1, 2. And when I put 2 in, I get 4 out. 2, 4. So as you can see, the graph that I'm getting looks like this. And now let's do the other one. Before we actually do that, let's take note of something. What is my y-axis? It's going to be 0, 1. And also take note of the fact, am I ever going to touch the x-axis here? And hopefully you can see that you're never going to touch it, because even if I was to make my x value like huge, let's make it -100. What would happen with my y value? Well, I would go y is equal to 2 raised to the -100. Y is equal to 1 on 2 to the 100, which is a very small number, but not 0. So what that tells me is that if I make x extremely small, or extremely negative, right? I'm never going to get to a place where my y value is going to be 0. It's just not going to happen. So what can we therefore say is happening here? And this is where I want you to draw this in. This is going to be an asymptote. This right here is going to be an asymptote. So y is equal to 0. All right, perfect. So we've got a intercept and we've got an asymptote. Let's now do our other one here. So let's put in our other one. So this is when we've got a base of 5. So if I've got a base of 5, we kind of go through the same process here. So that means I'm going to go y is equal to 5 raised to the -2. Hopefully you can get a sense of how this is operating now. This is going to be y is equal to 1 on 25. What will this one be? This will just be 1 on 5. This one will be, now this is an important one. If I was to let 0 be here, what's 5 raised to the 0? It's just 1. Do you see how that's the same as what we had over here? So you should be kind of picking up that when you've got a graph in this form, every time you put x equaling 1, x equals 0, you're going to get 1 out. So that means you've kind of got like a steady, always happening y-axis intercept. All right, this one would be 5, and this one would be 25. All right, if we now try to sketch this one, so take note of the difference here is the base. Here was 2, here was 5. How is that going to make things different? Well, now if we come here, hopefully you can see what's going to happen is that when I have x being equal to -2, it's even lower than there. It's 1 on 25. That's tiny. Then it's 1 on 5. It's going to be below there again. But then it's the same point here. And then 1 on 5 would be 1 on 5. And then 2 is 25. 2. Now that's going to be way off the graph. We can't even get there. But what I want you to take note of is how it's below there, but then above here. So that's kind of what you've got to get your head around, that when my base is a bigger number, I'm going to get smaller values for when my x's are negative, but I'm going to get bigger values for when my x's are positive. So that's kind of how you've got to think about it. So this green graph is y is equal to 5 to the x, and then this blue graph here is 2 to the x. Take note of the fact that our y-axis intercept is the same for both of them. And also take note of the fact that we still have the same asymptote occurring here. So now we can come here and we can just say some basic things. So what basic things can we say? So in general, the exponential function with the rule this, so where a is greater than 1, has the following properties, or have the following properties. As the magnitude of the negative x values become larger, so that means when I'm moving in this direction here, the y values get closer and closer to 0. So we saw that as we were going through it. You could see that as I'm going this way, as I'm getting bigger and bigger negative values, or as I'm getting smaller and smaller numbers, I'm getting smaller and smaller y values. But it never reaches 0. That is, the graph y is equal to ax approaches the x-axis from above. The x-axis is the x-axis is said to be an asymptote. Make sure that you underline, highlight that word there. We have an asymptote for these graphs. The way that you write that with proper notation is you say that as x is approaching negative infinity, y is approaching positive 0. So as x approaches the negative infinity, y approaches 0 from the positive side. That's how you read that off. What else can we say here? We can also say that as the x values increase, the y values increase. So no big surprises there. As we get bigger x values, we get bigger y values. The y-axis intercept is 0, 1. That was true for both of them. And the range of the function is all positive, all real positive numbers. So you're not getting any negative numbers there. They're all above the x-axis. So that is kind of the basics of how these work. I've also drawn it here on our CAS, so you can get a sense of what's happening. But yeah, that is the basics of an exponential and how they operate and how you sketch them. So hopefully you found this helpful, and I'll see you in the next part.